This is the second in a series of short videos on computational physics, and in this video I will be showing you how to use MATLAB to do simple calculations. As you can see, we have MATLAB already loaded, and as before we can ask MATLAB to do calculations by entering in appropriate expressions at the command window. So 2 plus 2 equals 4. So that's a pretty simple calculation. Let's do something a little bit more complicated. This time we're going to use variables. A variable is a name in which I can store some value. So for example, I can give a variable the name a and give it the value 1. And now if you look at the workspace window on the right hand side, you can see there is a new word that's been defined, a new variable that's been defined with the value 1. If I go back to the command window and I change that value, I type a equals 2, you can see that on the workspace on the right, that value a has been turned into 2. So the workspace contains a list of all the things that I've defined in this particular session of MATLAB. And a technical detail, for those of you that have used computer programming languages before, is that all these variables are in the so-called global scope. So they're available everywhere that MATLAB is running, at least this session of MATLAB. And of course, when I close down MATLAB and I reopen it, these variables will disappear. So I can define other variables. So let's define b equals 3. Now b equals 3. And of course, I can now do a plus b. And I get 5, of course. Now, if I were to change the value of a, now make a equals 4, and I now do a plus b, of course the answer changes. Now let's define c equals a plus b. That's also equal to 7 at this point. But if I change b, and now make that equal to 2 instead of 3, you can see that the value of c in the workspace on the right has not changed. If I ask for what the value of c is at the command window, you can see that it's still 7. So what this means is whenever I do the calculation c equals a plus b, it calculates the value of a plus b at that particular time and puts it into the variable c. So this is an immediate evaluation. It's not delayed in any way. So this differs from some programming languages, but is actually common to most. So that's how I can define simple single variable values. And of course I can define floating point numbers. I can do a equals 1.001, like so. And as before, you can see that MATLAB by default displays floating point numbers to 4 digits of precision. So let's display all of those digits of precision that are available by using the command format long. And I ask for the value of a again, and you can see that all the digits that are available within that variable are shown. If I now do a to the power of 20, say, you can see that that value starts to increase. Now, one thing I can do with variables is I can iterate them. I can take a value of a equals 1, and I can do a equals a plus 1. And now, of course, this takes the value that's on the right-hand side, the value that a returns on the right-hand side, adds 1 to it, and then puts it into a back again. If I now press the up arrow key on my keyboard, I can replay the previous command. So I can obtain the previous command, which is a equals a plus 1. If I now do that again, I get 3, and so on. So I can replay the same command again and again, and I can increment that value of a, which is a nice, useful feature of MATLAB. Let's do something else. Let's use our sine function again. So I'm going to type sine of pi over 2, and I get 1, as I would expect. But let's do something else. Rather than typing that command straight away, I'm going to type sine, and then I will hit an open bracket, and I will lift my fingers off the keyboard for a moment, and you can see that the sine function, if I put the open bracket there, suggests how to fill in the function. This is a very useful feature of MATLAB. It's called a contextual help, and it suggests to me that the sine function in this case is expecting a single value. So again, I can put in sine of pi in this case and I get 0. If I'm not quite sure about all the features that might be available in the sine function, I can ask for more help by clicking the help button. And I get an expanded help section which pops up in a separate window. I can also open up this thing called the help browser, and that will give me expanded information. And as you can see, if you look on the left hand side of this help browser, there are a number of different help sections that I can go to in order to help me to understand how to use each of the functions and the other elements of the MATLAB language, which is a very useful thing to have. So I'm just going to close that again. Something else I can do, if I want to find out about a function, I can do help sine. Let's try that. And you can see that it gives me a short version of the help function, and I can also go back to the help browser by hitting the dock button again. And there's that link that brings back the function. So as you can see, if I look in the functions that are available in MATLAB, there are the elementary math functions, which includes things like plus and minus. Let's click on the plus, and you can see that as well as having the traditional syntax, which is a plus b, I can also call that function by using the word plus and then the arguments a and b. So there are two ways that I can write the function plus in MATLAB, and again this is similar to other programming languages. If I close that down again, I can do, let's see if I can find those other functions again, arithmetic functions, where were they again? So if I go down again, I think let's have a look at DocSine. I'll click on the link because it's quicker, and there we are. Underneath arithmetic functions there are trigonometric functions, and all the usual trigonometric functions are available as you would expect in a modern programming language. If I scroll further down, you can see I have exponents and logarithms. You can see here I've got the exponent function, got the log function, log to the base 10, log to the base 2, and the square root function. Those are the ones that you will use most often. And of course there are other functions as well which are more complicated. And we'll come back to those a little bit later. Let's close that down. Now something I'd like to do, as well as manipulating single variables, is I'd like to manipulate sets of variables. So these are called arrays. So let's redefine the value a. So I'll click a equals, and now I'm going to give a list of values. And this will be a little confusing at first because we use the square bracket notation in MATLAB rather than other notations. So I'm going to do 1, 2, 3, 4. And I hit the close bracket sign, and you can see that the MATLAB command window is helping us by showing where those brackets are linked. So because I only have two brackets in this expression, when I used the close bracket on the right, it showed me where the corresponding open bracket was. This is very handy for debugging. So I hit return, and now I've defined an array A, and you can see up here on the right hand side that I defined the array, and if you look closely you can see that I didn't put commas in my definition, but those commas have appeared in the workspace record of the variable that I've defined. We'll come back to that a little bit later. So if I now ask for what the value of A is, I get 1, 2, 3, 4. Now here's a neat trick that you can do in MATLAB which isn't usually available in other programming languages. If I now type A plus 1, I now add 1 to every single value. This is what is called an iterable function. So whenever MATLAB is able to do so, it will try to apply the thing that you've asked for, in this case plus 1, and if you've asked plus 1 to be applied to the value A, and A happens to be an array of values, MATLAB will try to do the most appropriate thing it knows how to do. So in this case it will add 1 to each and every value of A, which is great. Let's try by comparison. I'm going to type B equals 3 again, and I'm going to do B to the power of 2. And I get the value 9, as I would expect, because what I've done is I've done B squared. Now if I go back to A and I do a to the power of 2, I don't get this. I get an error. And as you can see, this is because MATLAB, as the name suggests, if you look it up on Wikipedia, MATLAB means matrix laboratory, and MATLAB is actually expecting most of the time to be seeing matrices. So when it sees an array of values, 1, 2, 3, 4, actually it's expecting to see and do operations assuming that this thing is a matrix, in this case a one-dimensional matrix or a vector. So when I ask for a vector squared, it doesn't really know what to do with it. The easy way to get around this and the way to think about doing power operations on a set of values, like a single array of values, as this array A is to use the so-called dot notation. So rather than typing a to the power of 2, I type a dot to the power of 2, and now that square function does what I expect. It does 1 squared, 2 squared, 3 squared, and 4 squared. So this is something that trips up a lot of people initially, and it's something to be aware of when using MATLAB. In the next video, I'll show this in a little bit more detail.